Hey everybody. Today we are going to talk about vectors. This is not a big topic for VC, but it's sort of an important basis topic for our section on parametrics. Vectors are a way of analyzing motion for physics. And so position, velocity, and acceleration in calculus BC all go into two dimensions. And so vectors become an important way to uh, break down that information into a very accessible, very simple geometric way of looking at it. And nothing we're going to do here is terribly revolutionary. Let's say I start here and I move 3 units this way. So we'll say I've got a vector moving that way, and I have I turn and move 4 units up. Well, of course, you know that that motion is equivalent to making one trip that direction, and that one trip would be 5 units. And so that's a vector addition problem. If I take the long route, I travel 7 units. If I take the straight line path, that's 5 units. But in a vector point of view, we're just looking at where did you start and where did you end. You can use any means you want to get there, and that creates what we would call vector addition. So if I look at this as my x position, and I look at this as my y position, then this single vector that represents that total movement, I will designate it, and I'm just introducing some notation here, as the absolute value. In vector language, you call that the magnitude of the position change. And in terms of vectors, we would write this as x plus py. A lot of times with vectors, in a physics context, they'll draw little arrows above them like that, and that tells you that you're dealing with vectors. And what's interesting about this is that if I add vector the px and the py, I get the overall magnitude of the change in position. But that's not the same as writing it numerically. I don't write 5 equals 3 plus 4. Right? That's not true. And so vector addition happens geometrically, not using straight arithmetic. And of course, based on your experience with the great Pythagoras, you know that this 5 is actually the square root of 3 squared plus 4 squared. Okay. So when we add vectors in the x direction, a vector in the x direction with a vector in the y direction, that creates a right triangle. And so you add those using the Pythagorean theorem, not using straight addition. Right? And so that's one of the things that we're going to be dealing with here. I want to look at something that's a little more directly what we need, and that is to deal with velocity. The problems we're going to do are in with the parametric stuff are just particle motion problems like last year, but last year's particle motion problems were all one dimensional. This year's particle motion problems are all going to be two dimensional. And so in a particle motion problem from last year, which function would they give you? Well, almost always they give you the velocity function. And in a parametric problem, it's going to be the same thing. They're going to give you velocity information. And so when we're dealing with velocity, I'm going to say, okay, I've got an x velocity, and that's going to be the same as an x prime. I'm going to have a separate equation that's going to be my y velocity. And so that'll be a y prime equation. So you're going to have x prime and y prime independent equations. And when I add those up, I get the absolute value of the velocity or the magnitude of the velocity. Otherwise known, see if you remember this, I'll give you a second to think about it. What did we call that last year? Okay. We called that speed. So the magnitude of velocity is speed. So interestingly, in this class, when you're asked to do speed, it's going to be a little more complicated than last year. Last year, you had a single velocity function. You just put absolute values around it, and that was your speed equation. This year, if you want a speed equation, you're going to have to do the Pythagorean theorem with this x prime and y prime business. So that's all we're going to do on this video right now. I just wanted to hit this topic of vectors and vector addition, and that it relates directly to geometry and Pythagorean theorem. And so that will be, it's not going to be difficult. But the next lecture will be on parametrics, and then we'll start getting into the nitty gritty of how it all works. But that's it for this one. Signing off.